Hello, this is showcase number 4 for pre-calc. So we're given this problem. Station C is 10 miles due east of Station A. The bearing of Station B from Station A is 22 degrees true north. And the bearing of Station B from Station C is 305 degrees true. So I redrew the picture and then started labeling given the information. So we know that from A to C is 10 miles, so put that there. I then labeled my angles and my sides. So the side opposite the angle has the small version of that letter, so big C, little c is opposite. So the first thing I did was find angle A. So we're given the information that Station B is, the bearing of Station B from A is 22 degrees. So that means, well, from A, we got to go 22 degrees. And since it's true bearing, we're going to go from north 22 degrees, and that'll get us to Station B. So from north to back to A and then to C, that's a right angle, and we know that because it says that Station C is due east of Station A. So whatever this angle is, the total angle has to be 90. So 90 degrees minus 22 degrees gets us 68 degrees for angle A. The next thing I did, I looked at angle B because I felt like I had enough information to solve that. So if we extend our north line through B, we create basically two sets of alternate interior angles. And so like B, I like to think of it as a composite of two alternate interior angles. So we know that this angle is 22 degrees. That means that this angle has to be 22 degrees. That's just a property of alternate interior angles. So we have that angle. And then we know that C, the bearing of B from C is 305 degrees. So if we go from north all the way around to this line, that's 305 degrees. So that we know that a circle has 360 degrees, so this angle here has to be the difference between 360 and 305. So that'll get us 55 degrees. And that creates an alternate interior angle here. So if we add up 22 degrees and 55 degrees, we get 77 degrees for the angle of B. Angle C, we simply just take 180 degrees and subtract the two known angles, or the two solved angles, and we get 35 degrees. Now that we have all the angles and one side, we can find the distance between A and B. So this side C right here. So I use the law of sines to get the side of side C. So the sine of C, the sine of big C over little c is equal to the sine of B over small b. Through some algebra, came up and solved for C and then plugged in numbers. And then I got the question asked for the nearest tenth of a mile, so I did solve for this with the calculator, and it came out to like 5.888, something like that, and then I just rounded it to 5.9 miles. So that is that.